Welcome back. The other important concepts of CoreData is like feature results view controller and delete rules and multiple queues. Okay, these are the other important questions which are asked on CoreData. Feature results view controller. How do we use feature results? What is feature results view controller? Basically, feature results view controller is a view controller which is pointing to a particular entity, particular table. If any object is added, any record is added to the particular entity, that will be automatically displayed on the UIV controller. Basically, it maintains some notifications. Here we are having students view controller and schools view controller, right? You can attach the schools view controller, the schools entity, schools data table, which is there in the managed object model. The school entity you can attach to the fetched results view controller. So what happens when we save when we create any school here, automatically that will be fetched. What we are doing here in case of in general way, in the view will appear, we are loading it again. You don't need to load it. Automatically, the load operation will be performed once the record has been inserted, even deleted. Okay, we can simply register for some kind of notifications. Let me show you. But people ask, but you need to be aware of what is fetch results view controller. NS fetch results view controller delegate. Instead of explicitly calling the load method, the always it pointing to the latest data of the entity. Here, fetch results view controller is created and delegate installation the fetch request object context we are taking here. We need to create a request and a sorted descriptor. Sorted descriptor is which way it needs to be sorted. We have used a predicate. Predicate is to fetch the information, but here this is to sorting. Fetch request dot sort descriptors and fetch results view controller. Fetch results view controller. You are calling the fetch results. Actually, here we are pointing to the person entity. It points the fetch results view controller is associated with person now. In person table, person entity, if something is added or something is deleted or something is updated, those will be notified to the view controller by using delegate. Here we are having delegate fetch results view controller delegate. What is the method? We'll change content. Before changing the content, this method gets called did change object. Object is changed. We need to load and object is changed here. What is the method? Change type. What type of change it is, whether it is inserted or deleted or moved or updated. Based on that, we need to load here. Based on the change, we are performing operation. Basically, it provides some delegate methods where you need to did change content. There are three methods. One is will change. Another one is change type. Did change and change type. Third one is did change. In change type, whether it is deleted or updated or inserted or moved, based on that, we are performing operation on the table view. Okay, but this is the these are from delegate. NS fetch results controller delegate. Automatically, these methods will be called. There we are updating the table views instead of writing it on the view will appear. This is very helpful whenever you point to particular table, automatically the information will be displayed on the table view. Okay, it depends on the application uses. We use fetch results view controller, but there is one fetch results view controller. And coming to the next part, delete rules, very, very important. There are 4 delete rules. Let me check if I have any documentation for that. Yeah. Delete rules in CoreData. There are 4 delete rules. One is no action, cascade, uh, nullify, something really done. Let me check delete rules on CoreData. Deny. Yeah. Deny. These are the 4 delete rules. Very, very important. You will definitely face this question. What is the purpose of these delete rules? When there is there are relationships, like in our school, we are having relationship like one to one we have, and one to one we have, and one to many we have. Okay, let's say A and B are two entities, and A is pointing to the B. A has a relationship with the B. In case of in case of no action, if A is deleted, nothing happens to the B. If A is deleted, nothing happens to the B. Cascade. If A is deleted along with A, which are associated this entity, the B records will be deleted. Cascade means both. Nullify. If A is deleted, the objects which are associated with that particular object in A table will set to nil. Null. Deny. Let's say if I have a school here, in school, if there are few objects in school, let's say there are 10 schools. In one of the schools, there are 10 objects, 10 students. If I try to delete a school, it will not allow in case of deny, because there are some records associated with that school. There are some students which are associated with that school. There are some students which are associated with that school. That is the reason when you put deny, maybe here you can see the type. Nullify. Nullify means it simply sets the null. These are no action, nullify, cascade, and deny. In case of relationships. Okay. These are the 4 delete rules. I'm just repeating. No action. Let's say I'm having 5 schools. In one of the schools, there are 5 students. If you delete the school which is having 5 students, in case what happens is nothing happens to the B records. The students are left in the database itself. In case of cascade, if you delete the school, the students which are associated that school will be deleted in case of cascade. In case of nullify, if the school is deleted, for the student, the school relationship is set to nil, nothing, null. No school to that student. Deny. If there are any students which are associated with the school, then deny, when you set deny, the school will not be deleted because there are students which are associated with that particular school. These are the 4 cascade rules, very, very delete rules, very, very important. And multiple context and multiple queues. This is very, very important. Again, 1000% question. Can we use multiple context? The answer is yes, we can use multiple context. How can you? When do you create multiple context? By default, we get one context, that is persistent container.view context. This is the default context. This is also known as main queue. Most of the operations we perform on the main queue. Whatever we have performed so far for last 3-4 days, we use the same main queue. Okay. When do we use the background queue? When do we use the background queue? and multiple queues. In multiple queues can be used when there is any heavy lifting operation like inserting hundreds of records. Fetching more records. This is the heavy lifting operation which can be performed on the background queue or background context, we can say. Background context or private context or child context. Okay, the display operation, the fetch operation, we perform single fetch operation can be performed on the main context. The insertion operations which are heavy lifting can be performed on the private context or child context. This is the only case where we use when there is any heavy lifting operation which is not related to the UI, then we can use it. Then we can use separate context. We can create separate context and we can perform that heavy lifting operation on the child context. Okay, yes, we can use multiple contexts. One is private context, another one is the parent context, another one is the child context. The creation can be something like this. Maybe let me try that. Let me child context equal to CoreData manager dot shared dot context dot private context of child context. Perform wait. How to create child context? Concurrency type. Persistent content like this that view context is the main context. Persistent container dot new background context. This is the context which this is how we can create a private context or child context. Okay, and one more question which is frequently asked is let's say there are two contexts. One is the parent context, another one is the child context. Okay, let's say I'm performing insert operation on the child context, and I am trying to pull the information by using the parent context. In such cases, what happens is wherever we are saving, whenever we are saving child context, we also need to save the parent context to persist the information. Check. Okay, you need to save the two contexts to reflect the information on the actual entity. And can we use multiple persistent stores? Multiple by default, persistence store is internally using SQLite. Persistent store is a database, right? Internally, it uses SQLite. In addition to that, we can use binary and XML formats of persistent stores, but by default, it is SQLite. Maybe somewhere. In the previous version, it was like .SQLite something was mentioned here, but here it is not. Okay, by default is the SQLite kind of persistent store, but there are other ways, other types as well, binary and XML. And can we use multiple persistent stores? Yes, we can use multiple persistent stores, but these two things we use if the application is too big, then only we can use. Otherwise, single context and these things are enough. Relationships, whatever we have covered, entities, attributes, and delete rules. These are enough for the regular applications. If it is a heavy application, then only we can go for multiple context and multiple persistent stores. It is very rare, and One more thing is migration. Migration is there are two types of migration: heavy migration and lightweight. What is migration? Migration is, let's say today I have 5 tables in the version number 1. In version 1.0, I have 5 tables. In version 2, I want to add one more table, new table. In such case, what happens? Already in the user application, in the user device, already some data is already saved in 5 tables. I want to create a 6th table and want to insert some more data. We're actually, what we are doing, we're updating our database. We're updating our model. If you simply update it, what happens is that the application will not understand what is the new table. In such cases, we need to do migration. We need to do migration. Migration in the sense we create one more this kind of XE model, XE data model. The extension is actually XE data model. It is not showing here. Maybe if you see here, XE data model, the extension. Okay, you create one more this kind of XE data model, and you make that as active model. That is called migration. The lightweight, we do 2 kind of migrations. One is lightweight migration, another one is the heavyweight migration. Heavy migration we do when the types changed. Types changed in the sense, let's say the student age is today is string. I want to make that as integer. The type we are changing, and the relationship types. Today it is 1-to-1. Tomorrow we are trying to make that as 1-to-many. In such cases, we need to perform heavy migration. If you simply adding some entities, or some attributes, we can go with the lightweight migration, which is very simple. Maybe 2 lines of code which we need to write. Maybe go here and editor, add model version. Okay, I can take a V2. There are multiple versions here. If you see, there is a green check mark here. Green check mark is which is active. To use this one, how can we do this? I don't know. Is there any way to make it active? See the difference between this and this? There is no difference here. Yeah, somehow we need to make this active. The green check marks changes here, and in CoreData Manager, we need to write 2 lines of code to make that active. Let me show you. Lightweight migration, when we add new entities or new attributes, that case we use the lightweight migration. If the entity, like if the attribute types or relationship types are changed, then you go for a heavy migration, which is most of the people does not advise to do the heavy migration. Basically they add, that is complex as well to perform. Okay, CoreData migration, in order to follow CoreData migration, we should keep on worsening our XE data model file. Also, to add new changes, we should not make any changes in the existing data model. Here, whatever tables you want to add, you will add in the new model, not in the existing model. And adding entity, removing entity, renaming entity, and these are the changes which you are, whenever you are performing these kind of changes, you need to perform the migration. Attributes, adding an attribute, removing an attribute, renaming an attribute, relationship, adding a relationship, removing an relationship, renaming an relationship. This is what we did. Perform this. Yeah. Here we need to make this as active like this. Where is that? Model version. There are two models. You need to, if you want to make the new version as active, you can make this as active. The green check mark has been changed here, and we need to write one or two lines of code. Persistent store. Yeah, that's it. We need one lines of code. Here, what we are doing? Adding necessary support for migration description. NS persistent store description should migrate store automatically. Yes, true. Description should infer mapping mode automatically to true, and set those description to the persistent store descriptions on a container, persistent container. Only these lines of two lines of code or three lines of code, which is enough to perform lightweight migration. And heavy migration, let's see how to perform the heavy migration is suggestible. Heavy migration in CoreData. We perform heavy migration when we have either a normalized or generalized our database. In such cases, lightweight migration won't help us. We will automatically map attributes to the old model, the new model, and doing so is called heavy migration. What is migration? Heavy migration. A migration manager instance that performs a migration of database from one persistent store to another persistent store using given mapping model, NS mapping model, which is a class. Heavy migration. What is it? Heavy migration. Yeah, even you not find much help for the heavy migration because nobody says that, and nobody knows to. See here more details. I'm performing CoreData heavyweight migration on my app. I have created a mapping model made associated with NS entity mapping policy subclass and selected new model. If your model is not eligible for lightweight migration, then you have to add it, do it manually. Simply, this process can explained as reading records. Mapping models, progressive migration. Yeah, this is a little tricky one. Many things we need to do. But when do we perform? When do we perform the heavyweight migration is the important. When do we perform heavy migration? Now let's come to the topic below heavyweight migration and when do we perform it? So first of all, what does Apple say is use heavyweight or manual migration in rare cases when to change the data model exceed the capabilities of lightweight migration. If by using lightweight migration, if you are unable to perform something, then only go for heavyweight migration. In very rare cases, most of the cases we can perform it by using lightweight migration. You can find it simply by here. We can perform heavyweight migration when you have either normalized or generalized our database. In such cases, lightweight migration won't help. We will have to manually map attributes of old data model to the new data model, and doing it so called heavyweight. Basically, adding entity, removing entity can be done by using lightweight migration. If you want to transform the entire data, entire table into different table, in such cases, we can go for heavyweight migration. And even when the types are changed, the lightweight migration does not help. There are two types of migration. Yeah, lightweight migration you can use lightweight migration when new entity attribute relationship is added. Okay, an entity attribute relationship is removed. The name or type of entity attribute relationship is changed. Even changing also can be, the type also can be achieved by using the heavyweight migration. Not sorry, lightweight migration. Lightweight migration can help in these three different places. Even for the type change also, entity type, attribute type, or relationship type is changed. Then also we can perform lightweight migration. In this case, actually not required heavyweight actually. And when you want to completely transform your data into different tables, then you can go for manual migration or heavyweight migration. Okay. This is all about core data and the interview questions which are frequently asked. When to use let's read this. Yeah, you can cross check that like for the type change whether we can use a lightweight migration or heavy migration.